Okay, guys, welcome to our second day of review. So remember, we're going to place at the top review day 2. Today is December 9th, 2021. What is the topic that we need to see today? Today, we're going to see compound inequalities, okay? For compound inequalities, remember, we are still going to use the 3 specific rules that we have, which are variables will go on the left side. Okay, that's the first one. Variables go on the left side. The second one is that constants go on the right side. This ones you should know already. And the last one, and the most important and the most commonly forgotten, is that if a negative number passes multiplying or dividing, that slash is dividing, you flip the inequality sign. Okay, so we're going to say flip the sign. Those are the 3 specific rules that we're going to continue to work with. Now, we're going to work now with compound inequalities, and we have 2 types of compound inequalities. Which ones are they? Which ones are the 2 types of compound inequalities? We have the end inequality, okay? What are the characteristics of the end inequality? Is that you're going to have 2 inequality signs in one same exercise. Okay, you're going to have 2 inequality signs in one same exercise. Okay, and you graph towards each other or in between the numbers. Okay, we're going to say in between numbers. Okay, what does that mean? That you're going to graph from the point and from the point toward each other. That is the end inequality. Now we have the or inequality. What are the characteristics of the or inequality? Is that we will have 2 separated and different inequalities. And you're going to have the word or, okay? You're going to have the word or. You are going to graph in opposite directions. Okay, you're going to graph in opposite directions. What does that mean? It means that you're going to graph away from each other. Okay, you're going to graph away from each other. That is the or. We have a little note that we're going to add, okay? There's a little note that we're going to add. And that note says, end inequalities, once separated, because remember, we're going to separate them, okay? Once separated into 2, we'll have repeated the middle section of the original. Okay, you're going to have separated the middle section of the original. What does that mean? Let's do an exercise then to see what that means. Okay, so we are going to have, give me a second, an easy one. We're going to do 5 is less than k minus 2 less than 11. That is our first exercise. This is an end inequality. How do I know? Because I have 2 inequality signs, just like I told you. So we need to separate them. And it says in here that you're going to have repeated the middle section. That is because you're going to separate it from the beginning all the way to where the middle section finishes and that's your first inequality. And the second one will be right before the middle section begins, all the way to the left. Okay, and we're going to simplify those as two different inequalities, which you already know how to solve. And I added in here the 3 steps, kind of abbreviated, but they're there. So we have 5 is less than k minus 2, and k minus 2 is less than 11. That is our first exercise. So remember, variables go on the left. On the first one, the orange, yellowish one, do I have the variables on the left? No, right? I need to pass them to the left. If it's positive, it goes negative. And I need to have all of my constants on the right. I have this constant at the left of the inequality sign. So that one also goes negative, right? So now I'm going to have negative k is less than negative 2, because it's already there, minus 5. So negative k is less than, how much is negative 2 minus 5?
3 positive.
How much?
3.
7.
Negative 7, because same signs you add and you keep the sign. I didn't understand the question of the person that wrote on the chat. Okay, so I didn't understand the question. Now, we have a negative k. We're not looking for negative k, we're looking for positive k. So this basically means that there's an invisible 1 in there multiplying that k, negative 1. But instead of passing the negative 1 to the other side, dividing, and since it's negative, I need to flip. Instead of doing that, just because it's negative, I'm going to flip the sign, just a negative with no number, flipping the sign, and I'm changing the signs of every single side. So this was negative, now it's positive. This is negative, now it is positive as well. Okay, so there I have k is greater than 7. That's the first part. Let's do the second one. K minus 2 is less than 11. Again, variables on the left, only one variable, it's already on the left, constant in the right. I got this negative 2 that should go to the right, and it should go how?
Positive.
Positive, correct. So now we have k is greater than 11 plus 2. How much is 11 plus 2? $11 plus 2?
13.
13, very good. And now I have the 2 solutions. What else should I do? Or is that my final answer?
Graph.
I need to graph, right? So I'm going to graph. If you don't graph, you have your exercise incomplete. You need to graph using a ruler. So I use a ruler. I draw my arrowheads. I pick 2 locations for my numbers, and I decide which one goes first. Which number goes here?
13.
13? 13 goes here and 7 goes here. Is that correct?
No.
All right. How does it go then? 7 goes here because 7 is smaller and 13 is greater, so it goes at the right side. Remember, greater numbers, bigger numbers are always at the right side, and the smaller ones are on the left. Negatives are smaller than that. Now we're going to shade. But are they open or are they closed?
Open.
Open, right? So I'm going to graph this as an open and this also as an open. Now, I told you, and inequalities are graphed towards each other. but we can prove that. You see, k is greater than 7. So that means that I need to shade towards the right. But I'm going to stop right there where the number is. The other one is k less than 13, so it should go to the left. So I'm going to graph also up to where the other number is. So it actually is from point to point. That is how we're going to solve our first inequality. This is an end inequality. Questions about the end inequalities, anyone? No questions. Okay, let's do another one. Let's do an OR. Okay, we're gonna have 6w minus 1 is greater than or equal to 41, or negative 2w plus 1 is greater than or equal to 11. Okay, or inequalities are easier because you have already the word or. So you should know that if you have the word or, it is an or compound inequality. And or compound inequalities usually go in opposite sides. I think that the person that was asking in the chat, the question was, is it always going to be this way? That the end inequalities are always in between and the or inequalities go in opposite sides? No, it is not always like that. It is not usually like that. However, we are going to stick with this rules because you're going to learn those rules further on, either in Algebra 2, in 10th grade, or in 11th grade. Okay, so you're gonna get to see that further on. Right now, we're seeing the basics, and the basics are that the ends go in between and that the ors go in opposite sides. How do you know, or how are you going to know after if they go in opposite sides, if it is an or they don't go toward each other? Okay, because of the inequality signs. Okay, that's how you're gonna know, because of the inequality signs. Let's do this exercise. So we have already the two separated. I don't need to separate nothing like in this. In this case, they're not usually you're going to have different numbers. You're usually going to have different numbers, okay? Okay, so we have already separated in this. They're usually not repeated. You see, nothing is repeated. Like in this, we had k minus 2 repeated. In this case, I don't have nothing repeated, just the variable. It's the same. It has to be the same variable. So I'm ready to start solving this. Okay, so I need to leave the variables on the left. For the first one, it's already on the left. The constant's on the right. So this -1 should go to the opposite side, positive. So I'm going to say 6w is greater than or equal to 41 plus 1. 6w is greater than or equal. How much is 41 plus 1? 42, correct. Now I need to leave the variable completely alone. So this 6 is multiplying. How does it go to the other side? Dividing, very good. Should I flip the sign in this one? Should I flip the sign?
No,
Why not?
because it's not negative.
Because it is not negative, and the third rule applies only for the negative signs. Now we're going to have w is greater than or equal to 42 divided by 6. How much is 42 divided by 6?
7.
7.
7, exactly. Now we finished with the first part. Now we're going to go with the second part. The second part is over here. -2 plus 1 is greater than 11. So again, variables on the left, check. I have them on the left, constants on the right. So this one should go to this side, subtracted, right? Because it's positive. Okay, So what do I do now? I just go ahead and say negative 2w is greater than or equal to to 11 minus 1. Negative 2w is greater than or equal. How much is 11 minus 1? How much is 11 minus 1?
10.
Very good. Now I need to leave my variable alone, so this negative 2 goes to the other side. How?
Dividing.
Dividing. And what else?
Flipping the sign.
Flipping.
You flip the sign because the inequality sign, the number is negative, sorry. So it will no longer be greater than or equal. Now it is less than or equal. And we're going to have W is less than or equal to 10 divided by negative 2. How much is 10 divided by negative 2?
-5.
Negative 5. And now I'm ready to graph. So I'm going to graph using a ruler. I draw my arrowheads. I pick 2 different spots where I want my numbers to go. What number goes first?
-5.
Negative 5. And over here, 7.
Seven.
Are they open or are they closed?
Close.
They're closed. So I'm going to draw a circle, closed circle on top of my numbers, okay, according to the colors that I chose. And I told you that the or usually in these cases will go in opposite sides, but you can prove it. This is less than, so definitely it goes to this side. So you can graph it and shade it this way as well, or you can shade it like this, or you can just paint it however you want, but it has to be painted from the point all the way to the very end of your number line. And that would be your second exercise. Do you have any question about this? No? We're good? Okay, then let's see the third exercise that we're going to see today. The third exercise involves a fraction. So 3 is greater than 11 plus m, everything over 4, greater than or equal to -3. That is my inequality. You have a fraction right in the middle, okay? You have a fraction in there. So what can I do in here? Well, I can begin by separating them, okay? That's the very first thing, because this is an and inequality. Why do I know? Because we have 2 inequality signs. You see this one, both of them were less than. In this one, we have both of them greater than. But in this case, in the first one, we had the smallest number at the left. Here we have it at the right. And the greatest number, we had it at the right. Here we have it at the left. Does it matter? No, not really. It doesn't matter. As long as you have 2 inequality signs and they are, I'm going to explain this tomorrow in the other class, but they are basically the same thing. Okay, so we're going to rewrite them into separate ones. This is going to be the first one. Okay, like I told you, everything all the way to the middle. And this will be the second one, from the middle all the way to the right. Okay, so I'm going to say 3 is greater than 11 plus m over 4. That's the first inequality. The second inequality is 11 plus m, everything over 4, greater than or equal to -3. Okay, so I'm going to start solving this, but I have a fraction. So what is my very, very first step in these cases? How do I solve this? The very first thing, and we saw this on the very first day of reviews, Monday. What should I do to eliminate that fraction in there? Open your microphones. I cannot
Pass
open the
4
chat right now.
multiply.
Plus pass the 4 multiplying, because in order for us to eliminate a division, we need to pass it multiplying. Once that we have that and that there's no fraction involving a variable expression, I can continue with my rules. 3 times 4,
12.
12 is greater than 11 plus m. Now, according to my rules, I need to have my variables on the left. So I need to pass this m negative and constants on the right. So I need to pass this 12 also negative. So what do I have now? Now I have negative m is greater than 11 minus 12. Negative m is greater than, how much is 11 minus 12?
Negative
Negative 1.
Negative 1. Very good. And what do I do now? What should I do?
Divide.
Flip the sign.
I flip the sign, the inequality sign, and what else should I do? Change the number signs as well, right? So this is negative, it's now positive. This is negative, it is now positive. So now I have that m is less than 1. Okay, let's do the other one, the one in pink. Let's move it down here. Let's move it here next to each other. Okay, so I have now that I need to do the same thing. Eliminate that 4, it goes to the other side multiplying. Okay, that's the very first thing. So I have 11 plus m is greater than or equal negative 3 times 4,
Negative
Negative
12.
7.
negative 12. Variables should go on the left. They are already on the left. I only have 1. It is already at the left. Constants to the right. So this 11 goes also negative, right? Because it is positive. So I have m is greater than or equal to negative 12 minus 11. How much is negative 12 minus 11?
Negative 23.
Negative 23. What should I do now? Graph, very good. And you can see that sometimes you can have both of your inequalities open. Sometimes you can have both of your inequalities closed. Sometimes you can have one inequality open and one inequality closed. Which one goes closed in this case?
Negative 23.
Negative 23 is closed, so I've graphed it with a closed circle. Which one goes open? Well, the negative 1. Okay, so let's shade. Negative 1 is less than, therefore it means that we go to this side. Okay, to the left because it is less than. And negative 23 is greater than, so it goes to the right. Let's make this circle bigger. And that is how you graph an end inequality that is on the other way, backwards. Questions? No questions? Then basically, guys, this is the review for today.